Hello, and welcome back to Learning with Lee. In today's episode, we're going to introduce C++IO and take a look at some of how it differs from CIO. And the major difference between C++IO and CIO is that C++IO ends up using these two operators, this double greater than and this double less than, in order to do input and output. And that's because what it's actually doing is that it has objects for which those operators are defined. And if we pop over here, you can see some of these in which we have cin, cout, cerr, and all these are O streams or I streams. And technically there are wide character versions of those for WI stream, WO stream. And one of the major limitations of the standard library is that it does not actually have any binary streams by default. You can end up getting those through third-party libraries, you could create those on your own, but by default, these work on characters. And in general, that's enough in case you do need binary I/O operations. Then you typically are going to have to either handle that yourself, just use C, or end up using some third-party library that does that for you. So for this, these are typedefs of basic iStream, basic OStream. However, they're specifically designed to handle characters. And that's one of the major things is that you can see down here I have W characters. However, none of these are really designed to handle things as though they are bits or bytes. But you can see that it's characters and character traits. So you'd have to end up creating your own custom version of something like basic iStream in which it ends up handling these element traits correctly in order to do binary stuff. And you can see that over here in which it's then derived off of basic iOS. And these happen to be the general overviews of it. I'm not going to get too much into what's actually in here because a lot of this stuff is fairly complex, and by that I mean not even necessarily that the concepts themselves are complex, but it is very obfuscatedly written because it's designed to be highly efficient, not to be human readable. And that's because I/O, as I've said before, is one of the most expensive operations that you can be doing, so making certain that you maximize the efficiency of the rest of the code that's dealing with I/O operations means that you're really only limited by the actual transfer of data from either your memory to the screen or your memory to the hard drive, or wherever you happen to be doing the transfer to. You really want to minimize the amount of stuff that's going on that actually is between your code that's operating on the stuff and the buffer itself. Then you can see we have this basic iOS, which then is off of iOS base, which itself then is off of iOSB. And all of these have different aspects of streams, and most of these until we end up hitting something like basic iStream. So basic iOS, iOS base, and iOSB are used by both iStreams and OStreams. And the major things that they have is they have certain flags in order to tell you in case you're in a faulty state. It has certain flags to tell you how output should be formatted, so as that you can end up either adding flags or turning off flags. And that's how we end up doing things such as in case I wanted to output additional characters after a decimal point to have more precision, I can end up adjusting those flags in order to allow for that to happen, because similarly to C, in case you remember when we were dealing with fprintf, how it only by default outputs 6 characters, you're going to see that that's a similar problem with this for dealing with doubles and floats. Likewise, you can do things such as in case you want to output a boolean as either true or false rather than as 1 or 0, there happen to be flags for doing that. As well as there's a whole bunch of logic in here to make certain that whoever happens to be currently using that buffer in order to input or output something, they are the only ones modifying that data. You don't have multiple threads or multiple processes trying to operate on that data at the same time. That's very important to note. It's not something we're going to be getting into yet. We're going to be getting into multi-threading and how multiple processes work together and some of the problems that that can entail in the future once we get into some of the operating system concepts and a bit of the more low-level stuff in there. But for now, all you really need to know is that there's this whole bunch of different classes in a hierarchy. They're designed to abstract the concept of the buffers, the concept of file descriptors and file pointers that we were dealing with in C from us, so we can just treat these as objects and as operations. So really, that's the last we're going to be delving into those. If you want to on your own, you can definitely take a look through those. I mean, I would recommend it to a certain extent if you happen to be a bit more ambitious and you want to understand how it's working behind the scenes, but it's really a bit too complex to go into in this series. For now, all we're going to focus on is how you can actually use it. And it's very straightforward, very simple. So for this, if I then decide to run this, because I have several different things, so I'm going to start off with an integer. So I just do this, read it in, and then output it. Not a problem, ends up working out okay. One important thing, it's not always going to succeed on these try catches for this, even though these are actually objects and they do end up throwing exceptions at times. They have some fail states, and we'll get into those in the future when we start dealing with some of the flags that exist within these different streams. But for now, we can visualize it as though these could actually end up being hit for these tries and catches. Then we're going to read in a double. So for this, I'm just going to go with 0.654, 654, 654. But you'll note down here that, and you can just ignore this line for a second, but for right here, it happens to be outputting, once again, only the first 6 characters, and it rounds for us. And that is the same thing that happened in C, and there's a very good chance that it ends up using some of that same C code that we were dealing with earlier in order to handle this behind the scenes for us. It just is hiding that from us. Then you can even output, and if you really want to, you could read in pointers. I would highly recommend against ever reading in a pointer, because you don't want to actually deal with allowing the user to directly access memory. That is a terrible idea and should never be done. But you can output pointers, so as in case, let's say you have an error and you want to know certain information about it, you can end up outputting it this way. The one situation where you might want to output a pointer, though technically you're a bit better off in case you want to output it is something other than a pointer, is in case you're serializing some object into a form that you can store in a file, and you want something to refer to it by, you could use its pointer to it as an identifier. So it's in case you have other objects that are pointing to it, such in case we output our linked list, and I want to know what's before it and what's after in the list. I have to have some unique identifier for those links, and I can just use their addresses and use the pointers directly. However, the important thing is that if you use it as an identifier like that, to identify some object, you are not going to be inserted back at that same location in memory, and there's no guarantee that same location in memory will belong to you. So it makes a lot more sense when you end up reading it in case you end up doing that. You end up having to construct a table in order to basically translate from the old pointer to the new location. We might get into that in a bit for how you do that, but I don't think that's going to be something we do for quite a while. So it's really not necessarily that important, and quite frankly, it's a poor mechanism to use unless you happen to be dealing with fairly low-level implementations of things. Once we get to higher-level stuff, we'll either be dealing with integers or more likely GUIDs or UUIDs, which are globally unique identifiers or universally unique identifiers, depending on which culture of naming them you come from. One of the important things you can see here is that, in this case here, this address, and this is output in hexadecimal, but this address happens to be on the stack, and where it's pointing to, because I created a new int, is pointing to it on the heap. And the difference being is that this happens to be your free store where you end up having to actually allocate and then manually deallocate it later on, whereas this is the automatically generated portion of memory for your code during compilation, which it goes, oh hey, I'm going to need to put some int pointer or size of a pointer at this location, and it automatically has that prepared for you at the beginning of the operation of your program. Then you can input and output characters. So if I give it the character C, I can do that. I could hit that, click enter. I can give it a string of characters. So there, that. One of the important things to note about it is that it stops at a space. So even though these are all on one line, and I'm reading in this test character array here, it stops as soon as I hit a space. There are ways in which, as I mentioned with those flags, that you can disable that so that you don't stop at a space. And you might stop at a new line, and there are other ways in which you can end up delimiting that. But that happens to be something we'll get into probably in the next episode. But you can read it in, you can write it out, and you can write things out to see errors though you did see out, or really any other OStream. So you can imagine how files and strings, which we'll get into in a couple episodes, are treated the same way that cout, cin, and cerr are. for reading and writing these out, and they are similarly abstracted out because they were treated basically the same way as a buffer in C, so there's no reason not to treat them the same way in C++, just sort of hidden behind all of this information. Then also, as I was mentioning, you can output strings of long characters. It's important to remember that you just have to put this L before whatever string in order to specify that they are wchars. And really, that's all that we're going to cover in this one here, because this is just designed to be a basic introduction to it. And we've already covered some of this in the past, because, in case you remember, we've gone over things such as how to overload this particular operator for outputting our own different classes. And we'll go back over how to input and output classes, and we'll probably get into how to serialize our earlier example of polyhedrons and its I/O, because we've already, at least I've already implemented these operators here, and I'll get into exactly how those end up working and how we would then read those back in, provided on the assumption that it was output using this. So thank you very much for watching. Have a wonderful day.